Hello everyone, welcome to lesson 6-8, solve two-step inequalities. This lesson is found on page 513. Newspapers. Caitlin is placing an ad in the local newspaper for a pottery class. The cost of placing an ad is shown in the table. Okay, an ad is like an advertisement, and she's putting it on the newspaper for a pottery class. And these are the prices. So the service they're providing is a 10-day ad with only 3 lines. It's $38. So you can put up the advertisement for 10 days for $38, but it can only have 3 lines. Any additional line, so each additional line is going to cost $9 each. Okay? Complete the equation to find the total cost of C, which is cost. Okay, total cost is going to be represented with the variable C of an advertisement with 4 or more lines. Use X as the variable. So here's our X. Okay? So cost of a 10-day ad, we already know it's $38. Okay, $38. And we're going to find the cost of the ad for 4 or more lines. 4 or more. We know that this is 3, correct? This will get us 3 lines because it says it right there. And another line is going to cost us $9, but it could be more. So we're going to have to we know that we have to pay at least one more line, which is going to be $9, and the X represents possibly more. If it's only one line, the X is 1, and 9 times 1, and that's 4, right? Because here we have 3 lines plus the ad, and here we have one more line. But we don't know how many lines it's going to be, but we know that this right here is at least 4. And that's going to give us our cost. Okay? How much will it cost to place the ad if it's 5 lines long? Well, if it's 5 lines, that means we have our 3 here, and we got to have 2 here. And for each one, it's 9. So this X has to become 2. So your equation is going to look like this. 38 plus 9 times 2 equals your cost. So you multiply here, and you get your 18, okay? And 18 plus 38 is going to be 56. So your cost is 56. There we have it. Okay, suppose Caitlin can spend only $50 on the ad. Does she have enough money to place the ad? Circle yes or no. No, she only has $50, but it's going to cost $56. So no, she doesn't have enough money. She needs to only do 4 lines or less. She can only do that. If the answer is no, how much more money will Caitlin need? Explain. Well, she needs, it costs her, it's going to cost her $56. Sorry, yes, it's going to cost her $56, and she only has 50. So we're looking for the difference of the two. That means she needs $6 more. So she needs $6 more. Please copy this down. Pause now. So what is a two-step inequality? A two-step inequality is an inequality that contains 2 operations, hence the 2 steps. To solve a two-step inequality, use inverse operations to undo each operation in reverse order of operation, in reverse order of PEMDAS. Let's see here the example. So here we have 3x plus 4 is greater than or equal to 16. In PEMDAS order, we would do the multiplication first. But in reverse order, we're going to do the addition first. So we want to get rid of the addition by subtracting the 4. You see it right there. So we subtract the 4 out of it. And whatever we do to one side of the inequality, we must do to the other side. So when we subtract the 4, we're just left with the 3x. And on this side, we're left with 12. So 3x is greater to or equal to 9. Then let's divide out the 3. You see that? It's dividing out the 3 so that we can isolate the x. We divide out the 3 on the other side as well, and it tells us that x is greater than or equal to 4. So x has to be 5, 6, 7, it could be 4, but it has to be greater than 4. Graph the solution. You see it's a filled in dot, it's colored in. Okay, it's not hollow. If it's hollow, it means it wouldn't equal 4, but because it equals 4, it's colored in, and the number can be anything greater towards this side. Okay, for example 2, we have essentially the same. Okay, we would work in reverse order. In PEMDAS order, we would multiply first, but in reverse order, we would do the addition first. So we want to work out the addition. Let's undo the addition by subtracting the 5 out. You subtract it out here as well. Then the 4, you divide the 4 out, so you must divide the 4 out from this side, which you're left with just the x and the 7. So x has to be less than 7. Notice how it's hollow. The circle is hollow because it's not equal to 7 or less than 7. It's not less or equal to, it's just less than 7. So it's hollowed, not full, and then everything less than 7. Okay, 2x plus 8 is greater than 24. Let's work out the 8. Okay, take it out of there so that we have now, this cancels out, and we have 2x is greater than 16, right? Greater than 16 because 24 minus 8 is 16. And now divide the 2 out and divide the 2 out so that x has to be greater than 8. So then when we graph it, we know it has to be greater than 8. I'm going to draw a circle around 8 and not color it in because it's not equal to 8. It's just greater than 8 and color everything higher. So 8 can be anything in here. X can be anything in here. Not 8, but anything above 8, greater than 8. Please look at example 3 so that you can see how it also works with a negative number, okay? And how it is graphed for a negative number. X is less than negative 2, so less than negative 2 is going to be going this way, again, not colored in, but you would follow the same steps. Okay, now pay attention closely to example 4, because example 4 we're working with a fraction of a number. And in order to get rid of this fraction of a number, we have to multiply it by its multiplicative inverse. What that means is that if I want to get rid of, okay, the 2 right there, I have to multiply it, the 2 that you see right there, I have to multiply it by an inverse. And what I mean by that inverse is I'm going to multiply it by 2 over 1. Okay, I'm writing it as 1 because x to me right now is only 1x. Okay, so I've inverted this fraction. And if I'm going to do it on this side of the inequality, I also have to do it on this side of the inequality. Okay, here's the inequality. I have to do it on this side. So this side would also get multiplied by 2 over 1. Okay? You don't have to write it as 2 over 1. You could just write it as 2. But when you cross-reference multiplication, these two will cancel each other out. So you're left with just the x. Okay? Or x over 1, but you wouldn't write it over 1. And the same thing happens on the other side. But don't forget, we are working with the reverse order of PEMDAS, so really I have to get rid of the 5 first. I was just jumping the gun by explaining this first. So really what needs to take place is, so then following the steps the way we should, and sorry for jumping the gun, I was excited, let's get rid of the 5 first, okay? So that we get rid of the 5 by adding the 5. So negative 5 plus 5 is going to be 0. So we get rid of that. That's gone. But then if we do it on this side, we must do it on the other side. And negative 8, okay, plus 5 is going to be negative 3. So there we have it. Now we can do the multiplicative inverse that I was talking about. But here they didn't put it over 1. They just put the 2. So what happens here is these two cross-reference each other, okay? So the 2 is gone, and we're just left with the x. And on the other side, we have negative 3 times 2, okay, which is going to give me negative 6. So x is less than negative 6. And when you graph that, there's your negative 6. It's hollowed. It's not solid because it's not equal to. It's just less than. So we put it hollowed, and we go ahead and say that it's less than negative 6. You see that? Now we have these two examples. If you know how to do it, please pause the video now and then check your answer. If you don't know how to do it, then please go ahead and watch. But if you think you have a pretty good idea, pause the video, try it on your own. Really, challenge yourself. Okay, let's try the first one. So I've copied down the equation, right down over here. Okay. First I'm going to work out the 9 by subtracting 9 from both sides. Okay, it's canceled out there, and now I have I have x over 2, and negative 4 is greater than or equal to negative 4. Okay, and now I'm going to multiply both sides by 2, or 2 over 1. Okay, and this is canceled out so that I have x is greater than or equal to negative 8. So we have x is greater than or equal to negative 8. So negative 8 is solid. We colored it in, and we said it's greater than. X has to be greater than. You notice how it's going towards the positive numbers because its value it's greater. Okay, so that's the answer. Okay, same thing. Now we are going to get rid of this 8 over here that we have. Okay, that's 8, so and go ahead and subtract it out, okay, from both sides, so that this cancels itself out, and now I have negative x over 3 is less than or equal to negative 1, right? And now I'm going to multiply both sides by negative 3, because I'm going to take this negative here and apply to this 3 so that I can have my x all by itself. Remember, the negative sign can apply to the denominator or the numerator or the denominator. So I'm going to make it 3 so that they both cancel each other out. Okay, this side is also multiplied by negative 3. And because I'm multiplying this side by negative 3, okay, when you do that, it's going to change it to a positive number. So our sign has to change for the statement to be true. So now x is going to be greater than or equal to 3. Okay? So x is greater than or equal to 3. So it's greater than, so it's going to be this way, greater than. And it's equal to, so it has to be a solid color. And this is how you would graph it. Please take a look at example 5. Okay, we can look at it in class as well, but read through it and see how it's all set up, how they set up the numbers, and follow the steps so that you can see. You will need to know how to do example 5 for the independent practice questions. Essentially, it's only question 5 from the independent practice. Please leave the guided practice for class, and we will do the word problems, and you can see how to do the word problems as well. Complete the entire independent practice. Okay, here it is, in case you left your book at class. If you left it in class, please do it in a notebook. Okay? For number 10 to 13, we have to now work backwards. It's a bit of an abstract concept. But essentially what we're saying is, if you look here at number 10, what we're saying is that our variable has to be greater than 13. That's all we're saying. It has to be greater than 13. It doesn't have to be 13. It's not solid. It has to be greater than 13. So let's say our variable x, right, has to be greater than 13. And let's say I decide to multiply it by 4. Okay? 4 times, let's say 14. Okay? Or 4 times 15. Let's say it's 15. 4 times 15 is 60. It's 60. And let's say I add 1 to it. Okay, I'm going to add 1 to it. That's going to give me 61. And if I say that this side is greater than, I don't know, 53, okay, it's true. This equation, or not, this inequality that I wrote here can be supported by this graph. Because if x is greater than 13, this whole statement is true. Because 4 times 15, which is one of these numbers over here, 4 times 15 is 60, plus 1 is 61. And 61 is greater than 53. Okay, so here x, it has to be less than 6. Not 6, less than 6. Okay, so I'm going to go ahead and make this, I know that has to be 6. I'm going to go ahead and make it 5. It can be 5 if I wanted to, right? I'm going to choose 5. And for 5, I can say that, okay, so negative 2. I'm going to use integers just to make it more interesting. Negative 2 times 5 is negative 10, right? And if I add, let's say, 5 to it, negative 2, remember I made this 5, right? This is going to be 5, so it can be true. Negative 2 times 5 is negative 10, plus 5 is going to be negative 5. And negative 5 is going to be greater than negative 7. Negative 5 is greater than negative 7. So this statement here, boys and girls, makes this graph true. I want you to go ahead now and try 12 and 13 on your own. And keep in mind that this one is your x value has to be equal to or less than. Okay, and for 13 it has to be equal to or greater than. Okay, this is a key answer. See you in class.